Hey, what's up everyone? Welcome back to Next Gen Byte. Today we'll be looking at a very important technique in programming called two pointers. So let's start off by what basically are two pointers. So basically consider that you have an array of, as say, size n. Now to access a specific element of that array, you put in an index, alright, and you get its value. It's pretty straightforward. Now the thing is, what index you are using is also called a pointer. Alright, now as per the name suggests, two pointer, if you have two of these indices pointing at two different or same values, that is basically called a two pointer approach. Now, there are many types of two pointers. They can be parallel, etc., etc. But mainly, there are two kinds of main two pointer approaches. One is called converging, and one is called unidirectional. All right, I'm just going to write uni there to save some time. Now, as per the name suggests, converging means that two pointers converge, meaning if you have an array A, the two pointers basically moves one towards the right and one in the opposing direction. This is called converging pointers. Now, the second type of pointer we can have is unidirectional pointer. This means that if we have a certain array, then if one pointer moves towards the right, then the second pointer will also move towards the right, and vice versa. All right. So this is basically the main types of two-pointer approaches we have. All right, now let's look at a sample problem. So basically, let's say we have a binary string S. A binary string is basically like a string that only contains the elements 1 and 0. And our buddy Timur here can perform several operations. That is, if we have a string S, we can put 1 to one end and 0 to the other end, or we can put 0 to the left side and 1 to the right side. All right, so this is basically the kind of operations we have. Now we are given a final string. Okay, we don't have any initial string. We need to find out our final string. I'll call it f of s. Okay, and we need to check how many operations could Timur have done from an initial string to create the final string. Now let me explain this with a test case. An easier way to approach this problem will be thinking of, oh, how many pieces, how many elements can I remove from this final string? All right, so we're basically like kind of inverting our operations. Instead of adding, we are deleting our elements. All right, so let's say, is this operation possible? Yes, it is possible, since I said we can put 1 on the left end and 0 on the right end. All right, this is surely possible. So we can easily delete this. And this operation is also valid, since this here is 0 and here is 1. And as I said, also this operation is also valid. Okay, so we can also cut out this, and we can also cut out this. And now here, these two elements are same. And since, as you can see, it is not in our valid actions, we cannot remove this. So our initial string is 1, 0, 1, 1, which has a length of 4. Now, how to solve this with two pointers? We can have our pointer L and R, and we can choose our pointer here and the second pointer here. If these two don't match, we can move on to the next element and keep on moving to the next element until these two pointers match. Okay, and when they match, that is basically our breaking point, meaning we cannot do any further actions. So when iterating and decreasing our pointers, or more formally converging them into one another, we also keep track of the count. Alright, and when these pointers move, we increase our count variable. So this doesn't tell us the length of the final string, but this does tell us how much removals we need to do in order to attain our initial string. So by using some simple math, we can calculate the size of our initial string. Let me tell you how we can do that. Alright, since we are keeping track of count and removing two elements, this basically means that the total number of deletions, the total number of elements we delete are 2 multiplied by C. Alright, so we always do 2C deletions. And we also know that the string of the whole string is N. Alright, so we can just basically do N minus 2C to attain the size of our initial string. Okay, so yeah, now since we've understood the basic analogy on how to approach this problem, let's try to solve it. So here, as you can see, there are multiple test cases. So we get the input here. This is our length of the string, and this is our input string. So yeah, this is how I basically get my input from the serial. And now let's declare our two pointers, L and R. And as I said earlier, we'll set left to the leftmost item, which is at index 0, and R to the rightmost item, which is R is equal to N minus 1, since C++ follows zero-based indexing in arrays. And we'll also keep track of our count. I'm going to name it as C, and initially it will also be 0. Now we'll do if L is less or equals to R. We can just basically do if S of L does not match the right pointer, which is S of R, then we can move our left pointer towards the right and decrease our right pointer by 1, which means moving it towards the left, and also increase our count. Now, if our final value is reached, we can just basically break this loop. And in the end, we can return the length of the array, which is N minus 2 multiplied by C. And don't forget to put N line since there are multiple test cases. And let's test our program. Oh, silly mistake. This should be string, not string. And let's test it. This should be a while loop. As you can see, our program works successfully. Okay, it passes all test cases. So guys, this is it for today's video. I hope you like it. Thank you so much for watching. Please be sure to subscribe, be updated on more videos. See you next time.